All right, this is chapter 3-8, solving a system algebraically. Solving a system algebraically. So let's take a look at this. What we want to do is solve the system without graphing it, right? If we were to graph it, these two lines would meet somewhere. And the location at which these two lines intersect would be the solution to the system. But we don't have to actually graph it to solve it. This time we're going to solve it without graphing it. So what I want you to see here is that we're going to solve for X and we're going to solve for Y, and then we're going to have our ordered pair in that format. What I want you to see first is that Y equals X minus 3 and Y also equals 2X. Let me say that again. Y equals X minus 3, but Y is also the same as 2X. All right. So I need you to think about it as if your name was John and your last name was Peterson. If someone called you John or someone called you Peterson, it's the exact same person. So you can interchange those two names, Peterson or John, and still be talking about the same one. Why is that so relevant here? Because what I need you to understand is what we're going to do. We're going to replace this Y with that 2X. Okay? Since Y and 2X mean the same thing, where this Y is, I can replace it with 2X and rewrite the equation as, instead of Y equals, I'm going to write 2X equals X minus 3. See what I did? I took this 2X right here and I put it there. So now I have this. Why did I do that? Because I can't solve an equation that has more than one variable if I don't at least know what one of the variables, what it means or what it equals. So what I did in essence, I replaced the variable Y with a term that has X in it. So now if you look at this equation that says 2X equals X minus 3, I just solve for X. I don't have to worry about the Y right now. All right. So watch what I do to solve for X. I'm going to move this X away from the left side of the equation and put it over here on the, away from the right side and put it over here on the left side. Okay, let me do this. They will cancel. Okay. And look what I have here. What is 2X minus 1X? There's a 1 there. So you got to write that in. All right, 2X minus 1X is X. 1X, we just need to write the X, and that equals a negative 3. All right, so I just solved for X, but that's only part of the solution. I still need the other part of this solution. So on my ordered pair, I need an X and a Y. I don't have the Y part. So this X part does go here. All right. But I still need the Y part. So now what I'm going to do, I'm going to take this negative 3 and plug it back into one of these equations. It doesn't matter which one. All right. So I picked the second equation. Let's do that. Here the equation says Y equals 2 times X. Instead of writing the X this time, I'm going to write the solution for X, which is negative 3. Watch what I have now. Y equals negative 6. Y is negative 6. What does that mean? That means that my ordered pair is now negative 3, negative 6. That is the solution. Now, what does this whole thing mean? You can plug that into either one of those equations and solve it, and it'll be a solution. Let's try it. Let's plug it in so you can see it. The first equation says Y equals X minus 3. Let's plug in these numbers. This is the X. This is the Y. So negative 6 equals negative 3 minus 3. So let's work it out. Negative 6 equals negative 6. Does it work? Yes, it does. Let's use the other equation. Y equals 2X. Let's plug in these same two numbers again. For the Y, I'm going to have a negative 6. And for the x, I'm going to have a negative 3. Does it work? Does negative 6 equal negative 6? Yes, it does. So in other words, this solution will work in both equations. Let's look at this system. The first equation says y equals x plus 4. And the second equation says y equals 2. This is extremely convenient and easy. This is the way you want them to give you this problem. Why? Because one of them is already solved. Look at the second equation. It says y equals 2. You don't have to solve for y. You know why? Because y is already 2. So what I'm going to do is I'm going to take that 2. I'm going to take this 2 right here. Since y is 2, I'm going to take that 2 and substitute it up here so I can solve for x. I already know what y is. In other words, in my ordered pair part, my 2 is already here. I just don't know what goes here yet. Remember, this is x and this is y. Y is already 2. So now in the first equation, instead of writing y equals x plus 4, I'm going to replace the y with 2 equals x plus 4. And now look, all I got to do now is solve for x. How do I solve for x? I simply subtract 4 from both sides to get the x by itself. They will cancel, and negative 2 equals x. So my answer is negative 2, positive 2. That is the answer to the solution. Very good. All right, let's look at this particular question. We're going to solve this system of equations algebraically also. Let's look what it says. It says y equals 3x plus 8 and 8x plus 4y equals 12. There's something very interesting happening here. First of all, both of these equations are not written in slope-intercept form. One of them is written in standard form. So we really have to do a little bit more work so we can understand what's going on. First of all, we see that in the first equation, y and 3x plus 8 mean the same thing. So if I call this y, or if I call this 3x plus 8, it means the same thing. You can say either one. Keeping that in mind, what I'm going to do is I'm going to substitute this section. I'm going to take this and plug it in right here where the y is in the other equation. All right. So I'm going to rewrite this equation like this. I'm going to write the 8x again plus 4. But in these parentheses, instead of writing y, I'm going to write parentheses and write 3x plus 8. I am replacing the y with the 3x plus 8 because they mean the same thing. All right, equals 12. Now, you notice what I did was, instead of having an x and a y in the same equation, I now replaced the y value with something with an x in it. So now, this is my point. In this equation, I only have to solve for one variable. All right? So let's go ahead and do that. Let's go ahead and solve this. I'm going to do the distributive property here and here. All right? So let's do that. So what I have here is 8x plus 4 times 3x plus 4 times 8 equals 12. So what I'm going to do now, I'm going to just solve for x. So let's go ahead and multiply this and this. And now I have 8x plus 12x plus 32 equals 12. Now let's combine our like terms here. And now I have 20x plus 32 equals 12. I'm going to subtract 32 from both sides. Draw my line. They will cancel, right? And what do I have? I have 20x equals a negative 20. Right there, you see the negative sign? I have more negatives than positives, so it's going to be a negative 20. Now I want to divide both sides by 20. Why am I doing that? Because they will cancel. All right. And that leaves me with my answer of x equals a -1. Right? Now, x is -1, but that's just the x value. I still need the y value. So what we're going to do, we're going to take this value for -1 and plug it back into this first equation. Seems to be easier. That first equation, so that we can solve for y. All right. So let's write that equation over here again. Y equals 3x plus 8. That's the first equation. By the way, you can plug it into either equation. It doesn't matter. But let's plug it into the first one because the y value is already by itself. So it makes it a little easier. So where my x is in this equation, I'm going to replace it with a -1 so that I can now simply solve for y. This is -3 plus 8. So y equals 5. All right, y is 5. That means right here would be a 5. My answer is -1, 5. All right, very good.